Hi guys, and welcome to another lesson. Now we are going into programming GUIs with Tkinter library. So in this section we will find out how to create GUIs using a Python standard GUI toolkit, the Tkinter module. All GUIs are built on top of a toolkit of functions, or more commonly a class library. We'll look at some of the other toolkits that you can use with Python later in this in another lesson. But for now, the Tkinter toolkit provides a solid foundation for the basic principles. And we'll start off by examining some of the basic concepts of GUI design, including how GUI toolkits are structured and used. So let's start off by introducing the key GUI principles. Virtually all GUIs are event-driven. That means you need to write your code to respond to certain events generated by the GUI toolkit. GUIs come with a whole language of their own in terms of the objects from which a GUI is built. There are windows, frames, controls, and so on. And these objects are all connected by something called a containment tree. So we'll see what each of these concepts means and how they fit together to form a GUI very shortly. And also like to talk a little bit about event-based programming. We saw how programs can be event-driven back in section 2 when we worked with scripting. When we explored the parsing of XML and HTML files. Essentially, the parsers use an internal loop, and whenever they encounter an item of interest, they send a message to your code. In effect, they call the function that you provided. And this type of function is sometimes called a callback, because you register it with the framework and then the framework calls it back. GUI programming uses callback functions extensively. GUI programs function in a similar manner. The toolkit has an infinite loop within it, and the user clicks buttons, moves the mouse, or presses keys. The toolkit generates events that result in functions being called. We write functions and register them with particular events so that when a user selects, say the file, from file he selects the save menu item, and the function do file save gets called. This means the shape of your program code changes. Instead of you controlling the flow of the program from beginning to end, you instead initialize your data and then hand control over to the toolkit. This can be an unsettling experience for some programmers at first, but once you get used to it, you will find it actually frees you from a lot of mundane control flow programming and lets you focus on what your program needs to do. Now let's look at the GUI terminology. It's very important that we understand the words, and when we are mentioning them in the course, that you understand what they are. So one of the first things you notice when dealing with GUIs is the number of new terms you need to learn. You already met event, will no doubt be familiar with many more, such as menu, button, scroll bar, and so on. As a programmer, you find that sometimes the common understanding of terms is not quite what the programming meaning is. In addition, there are a bunch of other terms that are not usually exposed to users. So on the list that you see here on the presentation foil lists some of the most important GUI terms and their meaning from a programmer's perspective. So let's talk about the window term. And this is an area of the screen controlled by an application. Windows are usually rectangular, but some GUI environments permit other shapes. Windows can contain other windows, and frequently every single GUI control is treated as a window in its own right. And the term control. A control is a GUI object used for controlling the application. Controls have properties and usually generate events. Normally, controls correspond to application level objects, and the events are coupled to methods of the corresponding object, such that when an event occurs, the object executes one of its methods. And the next term is widget. It's a visible control. Some controls, such as timers, can be associated with a given window, but are not visible. Widgets are that subset of controls that are visible and can be manipulated by the user or programmer. And then we have frame. It's a type of widget used to group other widgets together. Often a frame is used to represent the complete window, and further frames are embedded within it. Frames sometimes have visible borders and background colors, but at other times are invisible and solely used as a container object. And then we have label. A label is a widget containing some text or a simple image. It does not generate any events, but can be modified in response to an event elsewhere. Then we have the button term. It's a widget with text and or images that can be pressed by the user and emits an event in response. And then we have next is text entry. It's a widget that can display and or receive text. It can be a single line entry on a form or a multi-line entry, such as a text editor pane. The text widgets can often contain other widgets such as images. Then we have the menu term. That's a widget representing a menu control. The menu contains menu items and or submenus. Menus provide all the mechanisms for the navigation of the menu widget hierarchy. Menu items, when selected, emit events that can be processed. Then we have the canvas term, and that's a widget for containing graphical shapes and images. Canvas objects normally contain methods that permit drawing of geometrical shapes, charts, and so on. Then we have the geometry term. It's and every window and widget has a geometry or set of coordinates indicating its location and size. Different toolkits represent this information differently. Tkinter uses the format width and height. Location information, if needed, is shown as x coordinate, y coordinate, and is relative to the containing widget. Then we have the dialog term. That's a special kind of window that is owned by the parent application but can be moved around the screen independently. Dialogs can be modal. That means you must close the dialog before the application responds to any other actions. Or modeless, where the dialog operates in parallel to the main application window. Then we have the message box, and we have played around with this. It's a small dialog box that generally presents very simple prompts or requests simple types of user input. We have already used Tkinter message boxes in the early examples. Then we have the layout term. Controls are laid out within a frame according to a particular set of rules or guidelines. These rules form a layout. The layout may be specified in a number of ways, either using on-screen coordinates specified in pixels, using relative positions to other components, left, top, etc., or using a grid or table arrangements. A coordinate system is easy to understand but difficult to manage when, for example, a window is resized. You are advised to use non-resizable windows if working with coordinate-based layouts. Better still, use non-coordinate layouts and let the toolkit manage things for you. Then we have the parent-child term. GUI applications tend to consist of a hierarchy of widget/controls. The top-level frame comprising the application window contains subframes that in turn contains still more frames or controls. These controls can be visualized as a tree structure with each control having a single parent and a number of children. In fact, it is normal for this structure to be stored explicitly by the widgets so that the programmer, or more commonly the GUI environment itself, can often perform some common action to a control and all of its children. For example, closing the topmost widget results in all of the child widgets being closed too. The containing widget is called the parent. And then we have the term focus. When a window gets focus, it becomes the active window in that all keystrokes and mouse clicks will go to that window and its child widgets. For example, a word processor may have a modeless dialog box for searches. The user can switch focus between the main window and the dialog by clicking with the mouse on whichever window it is to receive input from. And the next thing I want to talk to you about is the containment tree. And every GUI application is constructed in a tree-like manner with a top-level window containing other windows that in turn contain more windows until you eventually reach the lowest level controls and widgets. And this hierarchy can be represented as a tree structure and is known as the containment tree. Events arrive at a child widget, which if it is unable to handle it, passes the event to its parent, and so on up to the top level. Similarly, if a command is given to draw a widget, it will send the command on down to its children. Thus, a draw command to the top level widget redraws the entire application, whereas one sent to a button likely only redraws the button. This concept of events percolating up the tree and commands being pushed down is fundamental to understanding how GUIs operate at the programmer level. It is also the reason that you always need to specify a widget's parent when creating it, so that is known where it sits in the containment tree. So the example that you see on the screen right now is an example of a containment tree. And this illustrates the top level widget containing a single frame that represents the outermost window border. This in turn contains two more frames. The first contains a text entry widget and a label. And the second contains the two buttons used to control the application. So you can always refer back to this diagram when you get ready to build a simple GUI, which we are going to do right now. And for this, so now we're going to turn this discussion into a real code. So we'll try to build the application illustrated on this foil. And you can, to save some time, I have already included the demo1py file, which you can find in the zipped file. And it's in the folder called Tkinter. You have the demo1py. There are lots of other examples there as well. So copy that into the working directory of your IDE, or if you're working with a text editor, just remember where you have saved it and start it from there. So we start by importing the Tkinter and creating a top level widget. So we have seen that earlier in this lesson using the message boxes. So next we create a frame to hold all of the other widgets. This is done here. I'll explain this function in a bit. The first parameter of all widget creation methods is the parent widget. So in this case, we specify the parent as being top. The next step calls f.pack, and the pack function call, invokes a simple layout manager that by default simply packs components into the containing object, starting at the top and working down. We are packing our frame object into its parent, top, that represents the main window. The fill option tells the widget to expand to fill the window in both vertical and horizontal directions. We then create a second frame to hold the entry and label widgets. This is done here. And we use named parameter of the constructor to set a border around the entry widget and set the foreground color of the label font. Notice also that you are using arguments to tell the packer to place the widgets at the sides of the frame rather than its default vertical stacking arrangement. And you can see the usage pattern developing. Create a widget, then pack it. Finally, you pack the new f-entry frame itself. Here. One note is that a naming convention for widget variables is used in the example where the first character indicates the type of widget. This is sometimes useful as a reminder of what each variable is, but you can create a maintenance issue if you change the widget type later. The use of such a convention is entirely optional. It makes no difference to Python or Tkinter. And the next step is to create the buttons and associate some behavior with them. For that, we need to create an event handler that is activated when the user presses a button. And that is done here. Clears the text. The event handler sets the text of the L history label to the contents of the eHello entry field and then deletes the text from the eHello field itself. You use a directory style access to set the label's text. This technique works for any of the attributes of the widget. The delete method takes 0 as the first argument. That indicates the start of the text, and the special value tk.end used as the second argument means the end of the text. And then we create the buttons and connect the event handler with this block of code, which is here. So here, once again, we create a frame to hold the buttons, and then pack the buttons using side arguments. We also added some padding to the buttons so that we can create some space around them. The be clear button is connected to our event handler function by specifying the function name, which is evClear, as the command argument. The be quit button uses the predefined quit method on the top level frame F. So one thing you should be aware of is that it is very important that you specify the name of the function only and do not call it using parentheses after the name. Doing so would assign the return value of the function, in this case none, as the event handler. And then finally we start the Tkinter main loop running and wait for the user to do something. So let's try to run the code. So press enter. Clear the text. If you click the clear text, it just adds it on the side. And this is a very simple application. It's not so very sophisticated. And you'll find that you can resize, iconify, and move the window just like any other window on your desktop. Pressing the quit button will close the application. As does the usual close icon on the title bar. And pressing the clear button calls your evClear function. So referring back to the containment diagram, we can see that it describes the layout of this application with 3 frames, a label, an entry box, and 2 buttons. So now that we've seen the basics in action, we can move on to more realistic example using more widgets and linking the controls to more substantial event handling functions. So let's go back to our tic-tac-toe game. So we'll build a GUI version of the tic-tac-toe game in this section, and using exactly the same logic and data layers as previously. So this GUI is much more closer to the kind of GUI you would expect to see on a modern desktop application, complete with menus, buttons, and mouse interaction rather than relying on keyboard input. By using the same tic-tac-toe logic as before, we can focus on the structure of the GUI without thinking too much about how the application itself works. So when designing a UI, when building a substantial GUI application, it often helps to sketch out roughly what you want it to look like before jumping into code. For a tic-tac-toe, game, you want a menu bar with file and help menus. The file menu should have, if you work from our current code from previous lesson, the file menu has new, resume, save and exit menu items. You could have called the menu the game menu, but file is the conventional choice of GUI applications, and consistency of style is one of the advantages of using GUIs. And the help menu has help and about options. The board itself will be represented by 9 buttons laid out in the usual grid style. When a button is clicked, its label will display the player's mark. A status bar on the bottom will display messages to the user, and the final result will be a GUI representation using message boxes. So with a clear idea of layout, if you just roughly sketch it out, it's much more easier to find the examples, the code that you need for your program. If you just sketch it out by hand, for example, or if you like mockups, you can use mockup applications. So when you have a clear idea of the layout, you would now start to thinking about the code structure. The GUI essentially consists of 3 areas: the menu bar, the board, and the status bar in our case. The board needs to be treated as a group and centered in its frame, so you could make the board itself another frame inside the central frame. The status bar just displays text, so it will consist only of a label widget that just leaves the menu bar. So let's start building a menu for our game. Menus in Tkinter are a little more complex than the widgets we have used so far. The initial menu bar is actually quite easy to create because it's the default for a new menu. But how do you create the drop-down menus? The answer is that the menu class has a method called add_cascade that applies a submenu to a higher level menu. Tkinter knows about menus, so it automatically creates drop-down and pop-out menus as necessary without you having to do anything clever. The final anomaly to menus is that they are not added to the window using the normal layout manager method like pack. Instead, the top level widgets menu attributes is set to the top level menu object. Creating menus can become rather tiresome with a lot of repetitive typing, so it's often easier to model the menus as data and then use a loop to process the data structure into a menu hierarchy. And you can use that approach here even though your menus are actually quite short. So if you open the file which is called oxo_GUI_menu from the files that I have provided as a zip, you will find it in the OXO folder. It's called oxo_GUI_menu. So I'll go over the code. So after the initial imports and creation of the top level widget, you define the menu building function. The menu structure is defined as a set of nested tuples. The leaf node menu items consist of name function pairs. And we then create the top level menu bar object and loop over the data structure. building the submenus and inserting them into the menu bar. The complete menu bar object is returned. And the next section of code defines the event handler functions. At least it will do so when you are finished. For now, we just simply define a dummy function to handle all the events except evexit, which is trivial, and assign it to each of the event handler variables. Soon we return these variable assignments and convert them into definitions of the real event handling functions for our game. And finally, we execute the build menu function and assign the result to the top widget's menu attribute. And we then run the main loop function. When we run this program, we should get a menu with a menu bar, and when you select any of the menu item, it calls dummy function. So let's try to run it. So currently it's just dummy. So this is working, and the exit, I should of course test the exit, and it exits. Same with help, it just with it will be a dummy content. And the next step is to build a tic-tac-toe board. So having created the menu structure, we now want to extend the program to create the board. This sits within a frame that itself sits centrally inside of an outer frame. The reason for this design is that it separates out the tasks of laying out the board buttons from the layout of the board as a whole. In the same way that we did for the menus, we create a function that builds the board. The board is the part of the game that is connected to the logic layer and the basic gameplay, so that you also need to define code to convert the logical layers data model of a game into the displayed board within our GUI and vice versa. And you can do that in small helper functions. You also need to add an event handler function to set the button label when a button is clicked. The interplay between the GUI and the logic layer is also part of the button click event handler code. So let's tackle the GUI building part first. So just load, to save time, just load. I loaded the OXO_GUI_board from the zip file. I just load it in your interpreter, the IDE, or your text editor, whatever you are working with. And remember to have all the other files available in the same folder, because it's importing some of the logics and everything. So work in the same folder. So you have started to use some of the more cosmetic features of Tkinter to improve the widget's appearance and more clearly separate them on screen. In this case, we use the border and relief attributes. Let me see this here when we are building the board. as I said, we are going to use the border and relief attributes to make the board frame more clearly distinct from the menu and status bar. That also we defined here because it's just 2 extra lines and gets you close to our final GUI structure. We also set the color options for the status bar and anchor it to the bottom of the top level frame, signified by using the S for south. Here's the anchor. The board construction itself, it's just a couple of for loops creating the grid pattern. The width and height values were determined by trial and error. The command argument for the button is interesting because it uses the lambda function mechanism here. The reason for this is that the command argument must be a function that takes no arguments, but you need to pass in the row and column values. And you do that by setting up 2 default valued parameters where the values are the row and call values at the point of button creation. Each button calls the EV-click function with its own unique set of values. This is a common trick when programming with Tkinter. You also use the grid layout manager rather than the packer because the board layout is a perfect match to the grid style of layout. You simply specify the row and column locations of each control and the grid does the rest. So if we run the GUI board, and we will get a simple layout. Things are working, and we just get back information which cell we clicked, and the status bar is just telling us that it's testing. We are in the testing mode. So we'll complete this code very shortly. So now let's try to connect the GUI to the game. So having gotten the basic GUI structure in place, we can now turn our attention to writing the gameplay code and hooking up the various menus to the final event handling functions. We can tackle the game code first as it sits mainly in the EV-click event handler and is aided by a couple of helper functions that you can call cell2game and game2cells. So if you open up the Python file, which is called oxo_GUI_game.py, you have this code, and there might be some indentation errors here. Just go over the indentation. It just, in my IDE in PyCharm, it shows that it was used tabs instead of spaces, or an inconsistent use of tabs and spaces. And normally in PyCharm you get a option here to use spaces for tabs and as vice versa. So you can go over the error message and just the code's indented. It's indented correctly, but it's just how it used tabs. So just correct that before you run the code if you get any error. So it's just an tab error. So this is it is a modified code, and if you compare the EV-click code to the original play game function, you will see that there are many similarities. the game2 cells function is analogous to the original print game function, and the cell2 game function uses some widget methods to retrieve the child widgets, and in this case the buttons. You could have as an alternative stored the list of buttons in a global data structure that would have given more direct access. The game logic of user move, which is, where's the user move? Oh, it's importing it from one of the OXL logic. The game logic of user move and computer move is unchanged, even though the user interface is vastly different. So this is, I don't think it will currently working, but we need to fill in these event handlers, and that's what we'll do in the next step. So the game is over. So it's improvement from our vertical where we just clicked the cell and we got which cell was clicked. Now we get the game logic. Game logic is working, so we just need to fill in the event handlers in the menu, and these are almost trivial to complete, and the finished program you will find in the file which is called OXL GUI complete. So if you copy that file into the working directory, so I'll just pause the video and just correct the tab indentation error. So I'll just pause the video. So I just found out if you hover over the indentation error, you get a small light bulb. If you click that light bulb, you will get an option to convert the tabs into spaces, and it will do it for the whole file. So I just learned something new right now. So this is the complete game. So let's try to run the game. Let's just try this game. Try to run it again. Yep, it gets the saved state and resumes and exits. Help, we have the new help function and about function. So just study the code a little bit, and so we have just filled out the event handlers, really. That what we have added from the last module. and just the status texts of like for example game over. So the event functions mirror the original function in that they mostly just call the OXO_logic functions and then use the game2cells function to display the board. You now use the status text instead of the global game over flag. The help menus simply display text in a show info dialog. So there's a lot more you could do to add polish to this game, but it provides enough to show what can be done using Tkinter as a user interface toolkit, and illustrates once again the power of separating the logic and data layers from the presenting layer. You have now written more than 600 lines of code to play the various versions of tic-tac-toe. So that's enough for everyone. So it's time to move on to some other stuff. And Tkinter has many other widgets and tricks you can play with. Experiment with the simple GUI application that we started with and add or modify the different options that affect layout and appearance. You haven't even looked at how to display formatted text or images or plot graphs or build complex dialogues. All of these things are possible and built on the foundation you saw here. There are many Tkinter tutorials and sample programs around there, including idle, the default IDE for Python. So reading the code and seeing how these programs control appearance and use widgets is a great way to learn. And there is an excellent online tutorial on Tkinter programming available from New Mexico Tech, which includes some material on the newer features of Tkinter. You can find it here. What I did, I just googled New Mexico Tech Tkinter tutorial. So, but unfortunately it is based on the old Python 2 Tkinter package structure, so example need tweaking for version 3. And there is also one book, Python and Tkinter Programming by John Grayson, dedicated to Tkinter, that is quite out of date now, but does contain useful reference material and some longer, more sophisticated examples than you find in other tutorials. And Mark Lutz, Mark with K and L-U-T-Z, Lutz, his surname, also has extensive coverage of Tkinter in his massive reference work, Programming Python. And the latest edition of Lutz's books uses Python version 3, so it's worth looking into. So I wanted to round off this lesson by talking about extending Tkinter and mentioning two libraries called Tix and TTK. And the two biggest criticisms leveled at Tkinter are that it doesn't have enough widgets and it looks ugly. In comparison to the other GUI toolkits, these are valid issues. However, in recent releases, Tkinter has been fighting back with the introduction of two new modules built on top of Tkinter. These are Tix, which adds several new widgets, and TTK, which enables theming, which basically just means the GUI can look more like the native OS GUI. And both Tix and TTK are dependent on the underlying libraries from the TCL/TK project being installed. If you have problems getting Tix or TTK to work, check that the TCL/TK libraries are installed. Normally the Python installers do this for you, but sometimes conflicts can arise and you need to sort things out manually. Unfortunately, the documentation for these modules is not as comprehensive as you would want, and at the time of writing this course, the Python documentation often just contains links to the TCL/TK documentation. Once you get used to it, you can usually figure out what options you need from there, but it's not ideal. However, the Python of the Python interactive prompt comes to the rescue once again, because you can play with them and experiment to find out what they have to offer. Both modules support most of the same Tkinter widgets that we have used so far, so we should be able to take our Tkinter program and convert it to using TTK or TIX fairly easily. For TIX, let me just clear this out and start the Python interpreter. And for TIX, it is as simple as changing the Tkinter import line. This. So this is one of the best benefits of using the take key alias when importing. You don't need to change all of your Tkinter prefixes to TIX. You just simply set the import to use the same alias. You can try that on your tic-tac-toe game if you like. It functions identically to the Tkinter version, except that the title bar of the window displays TIX instead of TK. For TTK, it's marginally more complicated because TTK uses the Tkinter main loop and top level window, so you need to import both. You then refer to TTK when creating widgets and Tkinter when controlling the top window and event loops. So we'll see this in practice in just a moment. So because TIX is so similar to Tkinter, you can translate all you know about Tkinter into TIX and jumpstart into learning about the new widgets. There are more than 40 of them, but some are very poorly documented, even in the TCL/TK community. So if you stick to the subset listed on the Python documentation page, you should be fine. You only dip a toe in the water here, but hopefully it is enough to demonstrate that TIX is a valuable addition to the Tkinter family. The widgets that we are going to look at here are combo box and the scroll text and the notebook. And we'll see how a combo box input control can be used to set labels text by typing some code into the Python interactive prompt. I will just do that. I'll just import it as TIX. Just move it to the side. It should be small. excuse me, just a typo. It should be pick. So okay guys, I apologize, but I just had to retype the whole thing again. I just forgot one statement, and that was cb.pack, and then we'll get the combo boxes, and it displays up here what we have selected. So there are several things to note here. First, we use the config to set the text attribute rather than the dictionary style access we used previously. The advantage of config is that you can set multiple attributes at once just by passing them as named arguments. Second, the event handler lambda function uses a string argument s, which is passed in by the widget event. The string holds the currently selected value. And then we're going to explore the scrolled text widget. And the scrolled text widget is an extension of the standard text widget. As such, it can display images as well as formatted text. The Tix version adds scroll bars automatically, which is a useful addition that involves quite a lot of work using the standard toolkit. In use, it is very much like the other Tkinter widgets, and you can play around with it with some code. So if you just print out some text, it will show us the text bar is scrolling, and the windows shows the resulting text box with enough text to activate the vertical scroll bar. And you can simply type into the box manually or insert text programmatically. And the final widget that we are going to look at is an altogether more complex contraption. It is a notebook widget. It consists of a number of pages, each with an associated tab that the user can select to activate the page. The page is just a Tkinter container that can be populated with whatever controls you want to use. Often it is a text window or a form. We create a two-page notebook. The first pane containing a scroll text widget and the other a set of buttons that launch various message box dialogues. So we'll see the notebook in action, and you can, to save some time, you can just look at or copy the tix notebook.py file in the working directory. And let's run it, and I'll explain it in a minute. So this gives us just a text area, and then we have the different text boxes available. So in this example, we imported what's happening here is that we import the modules and create the top level of widgets as usual. We then created the tix notebook called notebook object called NB. To this we added a page called it page 1. And this is the page 1. And we added a text widget and some text, and then packed the widget and frame. Next, we created a second page called page 2 and added a frame to that page as before. We then created a bunch of buttons and linked them to the various message boxes using lambda functions as commands. We modified the pack options of both the buttons and the frame to make the buttons occupy the full width of the page, and we gave them different colors to make them stand out. And notice that for the notebook buttons and the scroll text widgets, we specify the expand option to the packer. Expand tells the layout manager to expand the widget when the window is resized. By using expand in combination with fill and anchor, you can very precisely control how your widgets behave when resizing the window. It is well worth experimenting with the options to get a feel for them. And finally, we started the main loop function. When we ran it, the results should have looked like the example that I showed you here, which shows both pages of the notebook in action. And I just want to mention the TTK. And TTK module brings the concept of themes to Tkinter and Python. A theme is a graphical style and enables the same GUI structure to take on the look and feel of the native operating system. There are several themes that ship with TTK, but you can also create bespoke themes of your own. The predefined themes vary by operating system, and you can find the names for your platform by looking at the output of ttk.style.theme_names. On Windows, they include Classic, the default, Win Native, Vista, and XP Native. TTK comes with its own version of 11 of the standard Tkinter widgets that are theme aware, as well as 6 new widgets of its own, including a combo box and notebook. You can change the look of application just by changing the theme. And so just take a look at TTK themings to play around with it. And that's all you really need to know about TTK for now. There are lots of options that you can play around with. You can even define your own styles and themes. Mostly you just use it as shown in the documentation, and you get small but significant improvements to your Tkinter program's look and feel. So that's it, guys, for GUI applications with Tkinter. And you have now successfully created your own game and played around with it and got it to work. So now you are set to exploring GUIs and also other options available that we are going to talk about in the next in the last lesson of this section. So we'll talk about local storage next. So see you in the next lesson.